So we looked at this slide actually. There's two slides in here that we looked at last module. I just want to review. We looked at think globally, act locally. The idea that we're always going to be globalizing our calls, and that can be either called, okay, so call-ed. I got picked on it at class this last week because in all of my modules I say call-ed. Now, I guess that's just a habit I've gotten into because called and calling can kind of blend together sometimes when I say that. So don't think that I actually in real life say call-ed and calling. I just emphasize heavily so that there isn't a... Okay, but we always modify or globalize, bring to a standardized, normalized format, either the calling or the call-ed or sometimes both, but we always do that at the ingress of the call. Now, that is different, as we talked about last module, from inbound call routing. Inbound call routing tends to signify that the call is coming from either a PSTN carrier or some sort of a trunk, maybe a ITSP, Internet Telephony Service Provider, or another cluster or something like that. But it's coming inbound to the CUCM cluster from the outside world. Okay, that's not what we're talking about when we say globalize at the ingress. There is the ingress of the call for inbound call routing, and that would typically be at the gateway or trunk level. But there's also the ingress of a call when the call originates from the cluster. So if an IP phone is registered to a cluster and the call comes in from that IP phone, in other words, the IP phone goes off hook and they begin to dial their digits, we can globalize their call-ed and optionally their calling number as well. And we're going to look at that quite a bit today, actually. And then even for that call, if they are placing, let's say, an IP phone is the ingress of the call and the call goes out ultimately to the PSTN, that would be viewed, or we would refer to it with terminology of an outbound call. But for an outbound call to the PSTN, there is still the ingress and the egress. So the ingress would be the IP phone going off hook and placing the call in on the line side of the cluster. And the egress would be what we see next, going out to a gateway and egressing to the PSTN carrier. So, and likewise, we can also, if we had an inbound call, that ingresses at the router that we see, the voice router there on the bottom left, and it egresses at most likely a IP phone there on the bottom right. So whenever the call is at its ingress stage, that's when we globalize the number. Call is at the egress of the stage, we localize the number. Now I want to bring up a real important and real quick point before we move on. And that is that, and I actually included this, a note to the same effect, in the reading resources PDF document full of links for last module, I believe 10, for the last module's reading resources. And that's simply to say that when you look at Cisco documentation, especially the SRND, the Solution Reference Network Design for Unified Communications Network 7.0, you'll see that Cisco actually talks about, or they refer to, localizing at the ingress, or actually they say localization at ingress and localization at the egress, and then globalization in the middle. So I just want to hit on that point real quick and define the difference, or actually the fact that there really is no difference. In fact, they are saying the same thing that I've been saying, which is that you perform globalization at the ingress and perform localization at the egress. What they mean when they say localization at ingress, globalization in the middle, localization at egress, it's just semantics. It's just the way that they're defining it a little bit different. But what they mean is that when, let's say, an IP phone user goes off hook, regardless of where they are in the world, they should be able to dial based on their local dialing habits. Because we cannot currently dial with the plus on the most of the IP phone keypads, a few like the dual mode, but for the most part we can't use the plus, then what we should do is have a localized format of dialing for our users. So if our users are in the US or the UK, they'll probably dial a 9 to hear secondary dial tone and get an outside trunk line. If they're in the rest of Europe, for the most part, they'll dial a 0 to get secondary dial tone. Then if they're in, let's say the rest of Europe, they'll dial 00 for international. Whereas if you were in the UK, you'd dial 900, and if you were in the US, you would dial 9011. All of those get you the same thing, which is international access, and none of those digits that I just mentioned, 000 from most of the EU, 900 from the UK, or 9011 from the US, none of those are actually digits that ultimately matter. None of them are digits that are part of the E164 format. I shouldn't say they don't ultimately matter. Some of those digits do need to be sent on to the PSTN, depending on your carrier. But the point is that everyone has local dialing habits. So that's what Cisco means when they say localization at the ingress. The user has a localized feeling. As soon as that happens, though, and the user dials locally, that's when we globalize the number. Okay? So I think it's just a little bit easier to say globalization at the ingress. But that's just my opinion, and I just wanted to clarify in case you're reading the Cisco documentation and you're wondering where the disconnect between my teaching style or what I've said and what you're reading on Cisco documentation. If you read it carefully enough, we're saying the same thing. Okay, so let's move on. And let's take a look at this slide again, this animation. So we looked at this last time. The idea is here we have a Seattle, Washington in the US IP phone, and we've got an Amsterdam, Netherlands IP phone. Okay, they're both a part of the same cluster. So at the Seattle phone, the user dials 9-206-501-5111. Okay, that's a local number. 9 outside dial tone and then 10 digits. Based on their calling search space, we globalize the call here at the ingress. They reach a translation pattern. If you recall from last module, translation patterns are the new route patterns. Okay, so we will typically refer to translation patterns as our PSTN patterns because there will be, in fact, other translation patterns that are not used for PSTN routing. Okay, so our PSTN pattern of 9 and then the local format. This happens to be specific to the North American numbering plan, but I will reiterate one time for those users that are not from the US, you don't have to panic. You will not need to know the North American numbering plan for the voice lab. They will tell you everything. And conversely, those in the US will not need to know international route plans and customary, 9 for outside dial tone or 0 or whatever, depending on where you're at. The lab will give you all of that specific information. So this PSTN pattern matches based on the partition, is able to be seen from the phone's calling search space. We discard pre-dot, that is we discard the 9, and we're looking to, in our PSTN patterns, we recall that we're always looking to discard anything that is not part of a proper E164 format. And so what we're going to do is we're going to prefix on what we know to be part of the E164 format. So +1, since this is a local call, we would prefix on, and it's got all the digits except for the country code. We prefix the plus and then a 1, which is the country code. This translation pattern has a calling search space that can only see the one partition or the one pattern in the one partition, which is the \+ bang or exclamation. And that's the one single route pattern that points to our one route list. The one route list has standard local route group. Standard local route group says go back to the calling party, device pool, grab its route group, its specific local route group, and then place the call out of that gateway. Now, the call is formatted as +1 and 10 digits, which the PSTN, in this case, is not going to route. Now, tomorrow, or the next module, depending on when you're watching this, we're going to be discussing CUBE and SIP ITSPs. And there are many SIP Internet Telephony Service providers that will accept plus as a standard character. So in that case, the call is already globalized or already localized for the carrier. But in this case, it's ISDN PRI, and the carrier, while ISDN will carry and accept the plus, this carrier won't route the call. So we have to localize it as it's going out the Seattle gateway. That is, we have to put it back into a basically 10-digit local dial format. And again, you might ask, especially if you've watched these few last modules spread out from each other, you might begin to question again, why did we do the work to globalize if we're only going to localize to the exact same format that it would have been in anyway? Why couldn't we have just dropped the 9? Well, that's mainly what today is about. If we remember and look at the ability to have, and we'll look at some specific drawings or whiteboards to remember what localizations we have, what call-ed party transformation patterns we have at each egress gateway. If we remember just the few called party transformation patterns that we have at each egress gateway, we remember that backup route groups or backup gateways, and what we're going to look at today, tail and hop off and everything else, really just works. And so that was the reason that we globalized it, so that it's in a standard format, and no matter if we route it at a local gateway or a national gateway somewhere else in our country or anywhere else in the world, the few localized egress called party transformation patterns that we have will take care of the format for all calls and make sure it's formatted properly for the carrier. So we do the localization at the egress, we said. So the gateway looks at its calling search space for call-ed party transformation patterns, sends the call up. A specific called party transformation pattern is matched, which is /+1.206, and we drop the pre-dot. If we weren't going to drop the 206, why did we have it in there? Well, because we wanted a more specific match than just /+1, which would match all national numbers. And for national or long distance, we would need to send the 1 to the carrier. So here we drop the pre-dot, a more specific match. And in this case, we're prefixing a 9. And the reason for that is we recall that this gateway in Seattle, or you may recall from our last demonstration and last deep dive, this gateway is actually a SIP gateway, so it's iOS, and if it's SIP or H323, we're going to actually send the 9 or whatever the secondary dial tone character is onto the iOS gateway. So here where you see this Seattle mouse, here where you see this Seattle gateway, this is actually a representation of the gateway as it's viewed from CUCM webpage. So in CUCM, device, and then gateway page, that's where we're sending it up to the called party transformation pattern and prefixing a 9. That way, when we send it out to the actual hardware iOS router, SIP gateway, it will match a dial peer that begins with 9. And the reason for that is, 1, so that we don't have overlapping dial plans or overlapping numbers. It could cause issue, especially as we begin to modify those and scale into the future, do ongoing administration. And then secondly, if this happens to need to be an SRST or CME as SRST gateway, the dial peers will already be in the proper format. Okay, and then the call goes out to the PSTN. So let's take a look at the next example briefly. A user at Amsterdam dials 00, so 0 for secondary dial tone, and then 010 for a long distance or national number to Rotterdam, which is 10 or 010, depending on how you're looking at it. 704-7444. So they match the PSTN translation pattern of 00 and then the remaining digits. I believe there's 9 remaining digits there. Now, the first 0 is secondary dial tone. We definitely want to strip that. The next is a national trunk code. And although most of Europe you'll see, in fact, much of the world, you'll see a 0 as part of what they consider their area code or geographic code, and I'm saying this for those that are not in the U.S., most of the area, you don't send that 0 on. Well, you send it onto the PSTN to indicate national, but it would not be considered, or it would not be dialed if dialing from internationally. So another way to put that is it's not part of the proper E164 full format. Now, there are some countries that is. I had a student in my class in London this past week from Italy. And I suppose in Italy, you not only send the 0 on normally, but if dialing internationally, that 0 is still prefixed. So it's going to be country by country. And all this is to say, kind of to reiterate, you don't need to know all of this stuff. The lab will tell you. So don't freak out about that. However, in this case, I'm the proctor, I'm writing the lab, so I'm telling you this 0 is not going to be sent on to the PSTN. Anyhow, so we're going to strip the double zeros because they're not part of the E164 number, and we'll prefix what is. What is the country code, 31 for the Netherlands, and a plus to indicate the country code. And the animation skipped a little bit ahead of me. It went to the route pattern, the single global route pattern, or so far. Today we'll add a few more. That goes to the single route list. Standard local route group looks back to calling party, device pool. Local route group is route group dash or underscore AMS for Amsterdam. We go out the Amsterdam PRI gateway. But before that, we need to localize the call at the egress. So the Amsterdam gateway has a calling search space for called party transformation branch to gateway. And we look at patterns that are in partition called party branch to gateway that match, such as backslash plus 31 dot. We see that we have this. We're stripping the backslash plus 31 and we're prefixing a 0. Okay, so we're prefixing the national code, and then the call is actually sent out to the gateway. Now, if you recall from last module, this was actually an MGCP gateway. So if it were a SIP or H323 iOS gateway, we would prefix 00. The other 0, the initial one dialed, again was secondary dial tone. Here we're only prefixing a single 0 because it's MGCP, which means that the Q931 layer 3 ISDN D channel is backhauled to CUCM. So CUCM is really in control of everything that gets sent out to the actual PRI PSTN carrier. It's only if it's H323 or SIP that we have any ability to modify it on the iOS gateway. Okay, so it's these egress. We've already focused last module on most of the ingress translation patterns, and we'll do a few more today because we're going to talk about globalizing a few more numbers. But it's these egress calling and called party transformation patterns that we're not even going to need to create any more of today. We've created the few that we need, and if we want, we can go back and review them. We'll certainly look at them on a whiteboard session here. But it's these few that are going to take care of everything else that we're going to be needing in terms of allowing the call routing. So the question now, what we want to focus on today is, now that we've done a brief recap, what else do we get with this globalization? What other benefits from having globalized our dial plan? Well, let's take a look at it. First of all, we get AAR, or automated alternate routing, for free. And we'll unpack what we mean by this. We also get call forward on unregister for free. We'll go into explaining all of this, what we mean by for free. And really what we mean by free, I'll just go ahead and give you the, the preview, is that we really don't have to do anything else additional to make this work, other than just quickly provision AAR or any of our call forwards. It just works now. We don't have to do any specific, site-specific, both from the calling site and where we are going out, the outbound call-ed or egress gateway. We don't have to do any specific digit manipulation. Everything has been handled by the inbound globalization of the called number, and then the egress localization, the few called party transformation patterns per gateway that will handle exactly how every call needs to be routed for every specific carrier that we've got an egress gateway for. THO, tail end hop off. It's not quite free. There is a little bit of configuration that we'll see today and work through, but it's nowhere near what we used to have to do. It's worlds easier than it was before. Emergency responder, site-specific failover for free. Again, we'll unpack each of these. Unified mobility, we've got a standard for our remote destinations that allow global usage. Extension mobility and device mobility, we've got expanded user dialing functionality while roaming. And then we've got one-touch standardized speed dials, corporate directory listings, dual mode, including dual mode phones, web-based click-to-dial, and missed received calls. So we'll go over and look at each of these. Missed received calls we certainly looked at last module, but we'll look at a little more today as well. So AAR for free. With automated alternate routing configuration, we used to have to do quite a few number of things. Now, we simply turn it on in service parameters. We create one group which has no prefixes, cluster-wide, one group. Doesn't matter if we've got gateways or phones, users in multiple cities, or even in multiple countries, inside of one cluster. It's still a recommended practice to have a separate AAR calling search space so that it doesn't happen to see any of our THO partitions. So we want to make sure that our THO partitions are not able to be seen by our AAR calling search space. Because THO, tail end hop off, the whole idea is that we route calls out the far gateway. Okay, so actually I should say the gateway where the called party is local. If I'm in Ohio in the US and I try to route a call out Beijing or a Melbourne gateway in Australia, for instance, it would make the most sense if I have a gateway there, obviously, or I should say if I'm trying to call a call-led party in that locale, either in China in general, and I've got a Beijing gateway, or specifically in Beijing, or specifically in Melbourne, and I have a gateway in Melbourne, it would make sense to try to route the call out that gateway. Well, now the only problem becomes with AAR, if I've got users that are in the Melbourne office, and I go to try to ring one of those users, but there's not enough WAN bandwidth, it invokes AAR, and AAR tries to use an alternate pattern, which is our new globalized AAR destination number, and that number matches a more specific tail-end hop-off number that tries to route the call out the Melbourne gateway. Well, the problem was, in the first place, there wasn't enough bandwidth to call the user in the Melbourne office, which is over IP. So why would I want to try to route the call out the Melbourne gateway where there also won't be enough bandwidth to get the call across? And also, why would I try to route it out that gateway just to route it back in the PSTN at that same gateway to call the user? None of it makes sense, and it won't work. So that's the reason that we want to make sure that our AAR calling search spaces still do not see tail-end hop-off partitions. So that's the reason to create another AAR CSS. But other than that, that's really the only caveat to watch out for. We don't need to change our external phone number masks if we don't want to. So with AAR, historically, we have had, or we have typically created an AAR group to prefix numbers to the called party's external phone number mask, the person that we couldn't get because there wasn't enough WAN bandwidth. And the problem is, now, especially if we're going to create one group that no longer needs any sort of prefix at all, then our external phone number mask has to be in plus format. Well, not every user wants to see at the top right-hand corner of their phone display plus country code, geographic code, and then their subscriber number. Many just want to see their geographic or area code and then their subscriber number. Well, this is not a problem now that we have the AAR destination mask on the line. We'll take a look at it in the task specifically for that. We just need to make sure that our AAR destination mask is in the globalized format. Then our external phone number mask can be in whatever format we want. We also get call forward on unregister for free. In fact, all call forward destinations that aren't going to be internal to our cluster or routed to another partner cluster, but any that are going out to the PSTN, all call forward destinations should be in the standard globalized plus dialing format. The call forward CSS determines the routing path, except in the case where standard local route group is used, and then the calling party, not the forwarding party, as the call forward indicates. The calling party determines the path. There is a way around this, and we'll look at that in later. But again, the egress gateways, called party transformation patterns, takes care of all the rest. THO for cheap. So tail-in hop-off still requires a small bit of work, and essentially what we'll do in the task today is we'll create one additional route pattern for each THO gateway we want to route out of, but it's very, very little compared to old dial plan method configuration that was needed. So we used to have to plan out and configure special tail-in hop-off routes, not only for the outbound destination, but really also based on who was calling. Okay, we used to have a specific pattern in a specific partition that would be visible from the specific site. Okay, even with line device approach, there would have to be one pattern per site. Now with standard local route group, we can have one pattern global. And then not only that, but we needed to format based on, well, one, specific because of how the user would dial the given number. We don't need to do that because all the PSTN patterns are defined as translation patterns. They do their called party digit manipulation. That is, they globalize the number immediately, and then that passes on to the route pattern. Once at the route pattern level, it matches the one globalized route pattern. So if we just create one more specific globalized route pattern, then the THO will match the more specific globalized route pattern and route out the very specific route group and ultimately gateway that we have defined. But we don't have to do any special digit manipulation any longer, again because of the egress called party transformation patterns. We also now have CER site-specific failover. So for those of you who have used Emergency Responder, if you've configured it or designed it, you know that CER, if a CER cluster were to go down, you would have a single backup emergency pattern based on your called party, based on the route pattern, the CTI route point that you would have provisioned. And that's no good. If I've got 12 offices, now you still need a separate CER per country or per area that you're going to have types of emergency numbers in. And you would probably have a publisher and a subscriber, a primary and a backup. But assuming that you do, we can, with globalized format, so globalizing, let's say 911 or 999, whatever the emergency number might be, once we globalize that number and then also use standard local route groups, failover to an emergency pattern looks back to the calling party, and with globalization, it looks to a single route pattern to look back to that standard local route group calling party and find the proper gateway out to route the call to, the proper local gateway. So it's globalization plus the standard local route group that gives us that functionality. Unified connect or single number reach. We used to have to take into account site-specific dial plan routing requirements to determine the format to put the remote destination number patterns in. Now we simply use the standard globalized plus format. And again, the egress gateways called party transformation patterns take care of the rest. And again, with extension and device mobility, both, and then also speed dials. We've said it enough by now that hopefully you're getting the picture. But everything gets entered into CUCM now as a standardized, globalized plus format of the number. And this also makes device mobility able to explore new options of only creating one device mobility group and allowing everyone the option of dialing in a completely standardized format from everywhere in the world that they might have need to travel. And we'll explore this actually much more in the next two deep dive modules where we talk about, I believe the first one is unified mobility, which is going to be unified connect or mobile connect or single number reach is another way that it's known, mobile voice access, and enterprise mid-call features. And then the deep dive module after that is going to be extension mobility and device mobility. Okay, so hopefully everyone sees, at least from a high-level conceptual point, that this globalization is going to be the key to really causing a lot of ease and convenience in the rest of our network design, deployment, and even much more so, growth and scalability. As we grow and scale, we need to do very little to the existing configuration to add on. But everything still just works.